Okay, for those of you listening at home, which may be anywhere from 1 to 7 people, hi, praying for you. I'm going to give you the notes that finally had homework 14B-1. That's the worksheet I gave out the other day, last week, Thursday or Friday. It's called odd even functions and solving with identity. So I need to explain what some of those things mean. So, write the following down, once I clear my space here. Did I go over, because I've gone over it with 2 different classes, did I go over what an odd function and an even function is? Do you remember that? Odd function versus even function? You probably remember the stories if I did. Okay. Brace yourself. The stories are strange. Not quite as strange as shooting cows, but pretty darn strange. There are 3 types of functions. Fns is abbreviation for functions. There's an odd function, well, even functions, right? The first type is an even function. Second type is an odd function. And the third is neither.
Is it 16?
I have the vaguest memory of doing this.
We did.
Okay. Does anybody happen to remember what's characteristic of an even function? Remember I was telling you about Stephen Wright, the guy who had the surreal joke?
Yeah.
The guy who wears... You know, the guy who the only way he played the harmonica was sticking it out the window when he was driving on Milner? Okay.
Yeah.
That's not important to the lesson, but they're talking about neither being kind of surreal. The key of this is what happens when you plug a negative value, or when you plug the opposite value in to an even function. Assume I'm even tempered. I could get positive input, like somebody gives me $50, or I could get negative input, like somebody just slashed my tires. How do I respond? If I am even tempered, how do I respond with positive input versus negative input? Remember? Take a 7, yes.
Comes out even.
The same, yeah. In other words, if you plug in a negative, I'll respond just the way I would if I had a positive input. So, for example, a relatively generic even function would be x squared. The way you test for odd hood and even hood, I'm pretty sure that's not a word. Try a number, plug in, and then try the opposite, and see what happens. Do you get the same answer, or do you get opposite answers? So if you make the input opposite, what happens to the output? That's right. Abby. Plug in a 2 into this thing. What do you get?
You get a negative 2.
Or just this one. So plug in 2 for x. So just f of x is x squared.
2 squared.
Right, which is
4.
4, and that's it. Now try the negative version.
Negative 2 squared.
Which is also 4. I got a positive answer both times. Does this look like an even function? Did it get the same answer for a negative input as it did for positive? Yeah, that's called an even function. An odd function, if you go negative on its input, it'll give you a negative output. Or an opposite, at least, it'll switch sign. If you switch the sign of the input, it'll switch the sign of the output. Example? F of x equals x cubed. Will, take this one. Try f of 3. Yeah, 3 cubed, which is 27. Nice. Try negative 3.
So it's negative 27?
Yeah. How do you get negative 27?
Because if you multiply it from -3, into -3, which is positive.
Right.
Then just multiply it by 3.
And then times another negative. So negative times negative times negative, yeah, gives you a negative. Did I get the same answer both times?
Did you?
Correct, did I? No, I got the opposite. So when the input went opposite, the output went opposite. What kind of function are we looking at here? That's an odd function. So this is an even function. This is an odd function. And what would a neither function look like? Example. F of x equals x squared plus x cubed. Let's try f of 2 and f of negative 2. Again, how do you test a function if it's even or odd? Plug in two inputs, one positive, one negative. I would not do 0 for what I hope for obvious reasons. Well, I tried 0 and I tried negative 0 and I didn't get any difference. Well, no, because 0 and negative 0 are the exact same number. So I would not try that. And on rare occasions where you get 0 as an answer, try again. It's not going to tell you anything very useful. Can somebody do f of 2 on this one? Okay. Go ahead and plug a 2 into this formula.
So,
2 squared plus 2 cubed. What do you get? 4 plus positive 8 is 12. Yeah. Now try negative 2. Okay. Okay. What is that? 4. Yeah, what do you get? Yeah. So did you get the exact same answer? No. Did you get the opposite of the answer? No. I got a completely bizarro answer. We got the first 5 minutes video if you're interested. So this just came to, like, here I got the same. Here I got the opposite. Here I got, what the heck? So if you have the same answer, it's even. If you have the opposite answer, it's odd. If you get something completely different, it's not. Does that make sense? I'll see. Grab your calculators. You need to test something. Let's just say g of x equals sine of x. I want to know if it's even or odd or not. Let's see. If I give you any old random function, how do you test for evenhood or oddhood, so to speak? Somebody's going to do that. Give me what you could. Like I tested f of x by plugging in a positive something and a negative something. So what do we do here? Go ahead.
You could substitute one of the common angles.
Yeah, pick any old number you want other than 0.
90 degrees.
90 degrees sounds good. 90 degrees, by the way, very good for picking one that's nice. If you pick the number 1 in here, it's not horrible. The sign of 1 degree is, although I want you to do it. Somebody please find, I want to test the sine of 1 degree. And then what else should I test in order to make this test work? If I try sine of 1, I should also try sine of what? Yeah, negative 1 degrees. Now you're going to give me a decimal answer, which is, it's all right. Give me the first 4 decimals, just enough to go on. Somebody type it in. Sine of 1 degree. What do you get? It should be a relatively small decimal. Yeah.
I got 0.0174.
0174 sounds right. Now type in sine of negative 1. So much, yeah, go.
Negative 0.0174.
Interesting. Negative 0.0174. that give you a verdict? Is sine even, odd, or neither?
Even?
It's even, it's what? Say again?
I said even.
Ah,
Oh, sorry, no, odd.
it's odd, correct. Even would give the exact same answer both times. Odd switches the sign. So yeah, correct. This is an odd function. Sine of x is odd. The sine function is odd. That's actually going to come in really handy in about 10 minutes. Try another one. H of x equals cosine. I'm getting lazy here. Even, odd, or neither? How do you test? Courtney, help me out here.
You would plug in a number.
Sure. Pick a different number other than 1.
Three.
3, sounds good. So what would you, how would you do that?
You do cosine of 30 degrees.
Cosine of 3 degrees, and then you'd also do what?
Cosine of negative 3 degrees.
Correct. Cosine of negative 3 degrees. See what happens. You're going to get a decimal, and it's going to be relatively large as far as cosines go. What do you get? Go ahead and try it.
0.9986.
9986. Okay, that's good enough. What did you get for the cosine of negative 3?
0.9986.
Interesting. What's your verdict?
It's even.
That's even. Because you got the exact same answer with a positive input as you do with a negative input. Cosine is an even function. That is becoming useful. I'm running out of letters. J of x is equal to tangent. I want to test tangent to see if it's odd, even, or neither. Even, odd, or neither. Blaze, help me out with this. How do I test?
You do tangent,
Yeah, pick a number.
what?
Tangent of, let's do one I haven't tried yet.
Oh, 4.
4, sounds good. Tangent of 4 degrees, but you can just do 5,000 if you want. Doesn't matter to me. And then you'd also have to do tangent of
Negative 4?
good degrees. Go ahead and punch in tangent of 4 degrees. What do you got?
0.0699.
0699 sounds good. Try tangent of negative 4.
0.0699. Or 90. Or negative.
Negative 0.0699. Blah, 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 blah. What's your verdict? Odd, even, or neither? It's an even function if you get the same answer both times. It's an odd function if you get opposite answers. It's neither if you get something completely psycho.
So it's odd.
That's an odd function. How many people were expecting neither? I mean, I did the first time I did this in high school. I said, well, it's odd, and then it's even, and then I figure out what's got to be neither. No, unfortunately. Sine is an odd function. Cosine is an even function. Tangent is an odd function. Let me try a couple things. These can actually get quite easy, believe it or not. Simplify. This is a trick question, I'll warn you. Sine of x over cosine of y. What is that in simplest form? What do you think? Well, let me ask you a question. Could I write this as tangent of something? Tangent is sine over cosine, right? Master formula number 2. Does that work?
No.
No. What's wrong?
Two variables.
You have 2 different letters. In other words, you can't do anything with it. You're stuck. If I had sine of x over cosine of x, we're in business. It'd be tangent of x. Now try this. Simplify. order to do the sine over cosine equals tangent trick, the inputs have to be identical. They cannot be different in any way at all. So what do you think? What's that? Correct. It looks like we cannot simplify it. Yet. Look at the top. Sine of negative x. Is sine even, odd, or not? Right there. Is what? It's odd. This is an odd function. If that's true, then what would you get when you did sine of negative x? What should the answer be, positive or negative? Negative. Everybody please write this. You get the negative answer. That seems like kind of magic that I just did. You can't just pull the negative out there in front. You're right. Usually I can. But this is an odd function. The definition of an odd function, which, darn it, I erased it. Look back at the previous one. An even function, f of negative x, will give you the exact same thing as f of x. An odd function looks like this. F of negative x equals negative f of x. That's what I used. I used that formula to transform. Since I knew this is odd, I used the odd formula. Plugging in a negative is the same as making the outside negative. I'm going to rewrite this. Negative sine of regular x, cosine of regular x. Guess what we have power to do now? Negative. Does this reduce? Did it have the same input this time?
Yeah.
Yes. So theoretically, we should rewrite it as what? Yeah. Tangent of x. And what's a negative divided by positive?
Negative.
Ta-da. Congratulations, you just did your first even odd simplification. This can help us reduce things that are otherwise impossible. Because you can't reduce things if their inputs are different. You can't do sine over cosine if the inputs are different. Watch this. Yeah. Sine of x minus cosine of x times sine of negative x minus plus cosine of x. I want you to simplify. Does anybody see an oddball in this problem that would just trip us up immediately? I mean, it's annoying. I'll be the first to admit that. But we could start foiling. There's no law against that. But there's something stopping us. There's something weird that would just throw a monkey wrench in the whole machine. And that's bad. You've heard of that metaphor, like throwing a monkey wrench into work. Yeah. Big, huge gears. Yeah, I wonder what the monkey wrench will do. Bad. Something in here is bad. Yeah. Randy, what's unusual in this problem? It is. This thing is, what the heck? Is there a way to rewrite that? Is sine even, odd, or not? It's odd. Can you rewrite that? By the way, these are totally normal. Don't rewrite them. Sine of x minus cosine of x. Just leave those alone. Can you rewrite this? Negative sine of x. A regular x plus, and then leave alone. See what we just did? The reason we did this is because it's You can rewrite it using the odd function definition. All right. FOIL. Go for it. Nate.
Negative sine squared.
Good. Negative sine squared of x.
Sine cosine.
Plus sine cosine. Sine of x cosine of x. Okay. Plus
Sine cosine.
sine cosine. Okay.
And then minus cosine squared.
Okay. Does anything combine or cancel or anything? Becca.
Two active.
Add what?
Cosines.
Yeah, these two. This is one sine cosine makes
Two sine.
two sine cosine. So 2 sine of x cosine of x. And then what's left over?
Negative sine.
Yeah, plus negative sine of square root of x plus
Negative cosine squared.
of x. This next part is trickier to see. I'm going to give you a little bit of a hint. Ignore the first part just for a second. What does this remind you of? The formulas in the past week. It looks a little different, but it's vaguely similar to something we've seen before. Don't worry about this first part yet. There are a few things wrong with it, but it has a haunting resemblance to one of the formulas they gave you. Yeah.
Reverse master formula.
First answer formula, what is that?
Cosine squared plus sine squared equals 1.
Yeah, cosine squared of x plus sine squared of x should equal 1. These are both negative, that's a bit of an issue. Watch this. Factor by grouping. Not the whole thing, just the right hand side. This is weird. Is that legal? Well, yeah, as long as you don't go too far. Leave the first part alone, in other words. 2 sine of x cosine of x. What's the GCF? Same.
Is it negative one?
Negative 1, that's all there is. What's left behind?
Sine squared of x plus cosine squared of x.
Interesting. What's sine squared of x plus cosine squared of x?
1.
It's 1. 2 sine of x cosine of x plus negative 1 times 1. And what is that?
Negative 1.
You got it. 2 sine of x cosine of x minus 1. Ding, 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 ding. You're done. That was a kind of a tedious problem, but I wanted to show you that one little step made it possible. If you hadn't done this would have been an impossible problem to do. You cannot multiply sine of x times sine of negative x. You could stick them next to each other, but they don't combine. Not in any useful way. You couldn't do sine squared of anything. Questions about it? All right. There are two main things I wanted to cover today. One was even odd, and the other is actually a long kept secret about trigonometry. Let me just show the words. But before we go too far, how much geometry do you remember? He asked, dodging the post-traumatic stress flashbacks that I could see on people's faces. We've got, all right, I get my visual clean. Does anybody remember first of all, can somebody find x? Yeah.
It's 928 degrees.
It's how much?
28.
How'd you get that?
90 degrees minus 62 degrees.
Yeah, 90 degrees minus 62. Does that make sense? If it's a right angle, it's 90 degrees, and then you subtract to find the leftover stuff. Nothing really starts. See, you survive. There's a geometry problem and nobody lost an arm. And, nobody's laid up in the hospital with broken ribs or anything like that. But there's a name for this. 62 degrees and 28 degrees, they add up to 90, right? They're what we call what kind of angles? There's a special name for two angles that add up to 90. There's another name for things that add up to 180. Go ahead.
Complementary.
They're called complementary. They are complements. By the way, spelling people. Complement with an E. Yeah.
I use that.
Oh, sorry, go ahead. Yeah. Complement is a geometry term. This, by the way, is as opposed to complement, which is my what a lovely hat you're wearing this morning. That's saying something nice about somebody else. This is being socially nice. This is the sum is 90 degrees. Anybody remember the name for two things that add up to 180? Yeah. Supplementary. Yeah. Supplementary are two angles that add up to 180. Complements are things that add up to 90. So supplements add up to 180. Complements add up to 90. Why did I tell you that? I told you that to tell you this. Here are the full names of the first two trig functions, written out with all the letters. You'll notice that they sound a little bit alike. There's sine and sine in both of them, but there's a co here. That's actually an abbreviation. Does anybody have a guess as to what it might be an abbreviation for? Yeah. The full name is complement sine, or cosine for short. Why do I say that? Grab your calculators. I'm going to try something. Before we do, go ahead and have your calculator ready. I'm going to give you an angle, and I want you to find the complement of the angle. Okay? So, for example, 10 degrees. Can somebody tell me its complement? Yeah. 80. How do you get that so fast?
90 minus 10.
Right, it's 90 minus 10. So whatever adds up to 90. What if I had 2 degrees? Rain. What's the complement of 2? What's that? 88. How do you get that so fast? 90 minus 2, right. What if I do this? Theta. What's the complement? Yeah. 90 degrees minus theta. You see, it's the exact same trick. This is 90 degrees minus 10. This is 90 degrees minus 2. This is 90 degrees minus the thing. So, calculators are they ready? Can somebody, let's try that in English. Can somebody please tell me the sine of 10 degrees? Roughly. It'll be a weird decimal. Give me the first 4. Yeah, go ahead. 1.1736? Can you give me the cosine of 80? Right. 0.1736. How interesting. What do 10 and 80 have in common? How do they relate to each other? Right, right. They're definitely multiples of 10. That was kind of an accident. I was trying to make it nice. Which means they add up to? Let's try one more. What's the sine of 1 degree? I think we did this earlier. And I erased it, sorry. Somebody have it? Sine of 1 degree, go. 0.0174. Just out of curiosity, was it 0.01736? Probably not. Never mind. I was just curious. I was wondering if 1 and 10 would, never mind. What is the complement of 1 degree, by the way? just off the top of your head? What's the complement of 1 degree? 89. Do me a favor, find me the cosine of 89.
It's the same thing.
0.0174. Ding, 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 ding. The sine of one angle is the cosine of the complement. That's what they call a complement sine. And even more than that. Oh, math people, look at your calculators. Where is the secant key? Turn this stupid mask, you can't think smart. Where's the secant key? Oh, come on. I kid. Where is it? It's not there. You don't have one. There is no such thing as a secant key. How do you find secant? What is secant? Yeah.
You do 1 over, cosine.
1 over cosine. Yeah. There's no such thing as a secant key because you do 1 divided by cosine. So, here's my question. Can somebody find me the secant of 2 degrees? Like, what would you actually type into a calculator to get this? Yeah.
1 divided by cosine.
1 divided by the cosine of 2. Go ahead and do that. Don't forget to close the parentheses when you do this. Yeah.
1.0006.
That sounds about right. Approximately 1.006. 1.0006 or?
Yeah.
Okay. Okay. Can somebody pronounce this for me? He says, tripping over the pronunciation.
Cosecant.
Cosecant. Guess what it's called? Cosecant. It's complement of secant. By the way, guess why they call it cotangent? It's the complement of tangent. They match up. Nobody knew, except the people that designed it. Can somebody find the cosecant of 88 degrees? How do you type that in? What is cosecant? Just regular cosecant. Reciprocal of sine, so it's 1 over the sine of 88. Somebody type that in for me. What do you get? Okay, go for it.
1.0006.
Interesting. You see how this works? Yeah. Go for it. Leave the door cracked, you can back in. See how this works? Look up here. Here's the actual chart. The sine of theta is equal to the cosine of 90 degrees minus theta. Also, the cosine of theta is equal to the sine of 90 degrees minus theta. It works both ways. Make sense? You can also do tangent and cotangent, and vice versa. You can also do secant and cosecant, and vice versa. Make sense? Now let me throw a little curveball at you. A lot of people get this wrong because they work way, way, way too hard. If you see the trick, you can answer it in about a second and a half, depending on how fast your brain works. If the cosine of some weird angle is 0.7, what is the sine of 90 degrees minus theta? I didn't even tell you what theta was. What a cruel problem? Think you have the answer? It is not. Good guess, but no.
It's like 0.7.
0.7. Try an actual angle. In other words, if the cosine of 10 degrees is 0.7, what's the sine of 80? It'll be the exact same answer. Make sense? Sine is equal to the cosine of the complement. Cosine is equal to the sine of the complement. As long as these are complementary, they only add up to 90, and check, like theta minus theta, they cancel, they give you 90. They give you the exact same answer. Oh, by the way, let me play with your mind. Let's do it in radians. No, not radians. They're horrible. They're fine. If the tangent of some weird theta is equal to 2, then what is the cotangent of pi over 2 minus theta? It's actually an easier problem than you think. Can somebody tell me what pi over 2 is? What degree measure is that? Go. 9 degrees. Ever recognize this 90 minus theta business? What is that? It's called a what? Starts with a C. My, what a lovely suit you're wearing. Yeah.
Complement.
Complement, right. This is the complement of theta. This is the complement of theta. They just happen to write it in radians. This is the exact same thing as this, just in radians instead of degrees. Give me know the answer? Take a while to have a guess. It's 2. It's 2. Take out, please, your worksheet 14B-1 from the other week, other day, or Thursday, Friday, I forget which one I called it. When I handed it out. It's 14 problems, 1 through 10 on the first page, and 1 through 14 on the second page. I'm splitting this into 2 parts. You're not going to do the whole thing for tomorrow. You're going to be doing 1 through 10. There are a couple of curveballs in there. Look at number 6. Let's do this together. Number 6, it should say, if the cotangent of theta is negative 11.43, find the tangent of pi over 2 minus theta. You want me to do it to me? Okay, what do you think? If the cotangent of this mystery angle is negative 11.43, what's the tangent of pi over 2 minus that theta? It is a negative 11.43. It's the exact same answer. Cotangent of the angle is the same as the tangent of its complement. And pi over 2 minus theta is cos of complement. Now you might have noticed that some of these have weird inputs. Some of them have pi over 2 minus theta, and some of them have negative theta. The negative thetas are from the first part of the hour. That's the odd, even, neither thing. Let's try number 1 together. This you cannot do directly. They're giving this, number 1, sine of negative theta is equal to negative 0.53. And they want to know the cosine of pi over 2 minus theta. Ever recognize that this is a complement? The cosine of the complement should be equal to the sine. But we have a little bit of a problem. Anybody see it? What's messing up our problem? Kind of like we messed up our problem 10 minutes ago. Nate, what's wrong with this? We have a negative theta. It doesn't work if I have a negative theta. I've got to get rid of that negative theta. Tell me how. Will, help me out here. How do you get rid of that negative in the input? Quick reminder, is sine even, odd, or neither? It's odd. What happens when you plug a negative into odd? Does the answer stay or turn negative?
It turns negative.
Yes, tell me what this really is then.
So negative sign, with negative sign theta.
A regular old theta equals negative 0.53. Can you get just sine of theta by itself? One little step.
Yeah, just multiply both sides by negative one.
Multiply or divide both sides by negative 1. Multiply is fine. So we're going to rewrite this. Sine of theta is equal to positive 0.53. Can somebody tell me the cosine of the complement now? Believe it or not, it should be fall off a log easy. It's 0.53. Once you have regular sine of regular theta, then the cosine of the complement is identical. The only curveball they threw is that they tried negative theta to see if they could fool you, and they didn't. Okay, so beware. Number 1, 2, 3, 4, 5, there are negatives in there. Oh, look at number 5. I'll give you a hint. Secant of negative theta. Is secant even, odd, or neither? We didn't test it, but there's a way to tell pretty quickly. What is secant? Yeah.
Even,
How do you know secant is even? That's correct.
because it's inverse of cosine.
Not inverse, but it's the reciprocal of cosine. If it's 1 over cosine and cosine is even, then secant is even. Basically, if secant is even, cosine is even. What about cosecant? Can you tell me if that's even, odd, or neither? Cosecant? Kidding.
It would be,
It's odd, because sine is odd. What about cotangent, Becca? Even, odd, or neither? Cotangent. It is odd. Why? Because tangent's odd. Correct. So treat it the same way. Number 5, secant of negative theta, that's going to be an even function. So what's secant of regular theta? I'll give you the first half of this. Somebody help me out? What's secant of regular theta if secant is even? Does the sign switch or stay the same? Tell me. If it's even,
It stay the same.
stays the same. It started negative, that's not our fault. It stays negative. So in other words, secant of regular theta is still equal to negative 1. Even functions, the sign doesn't switch. Odd functions, the sign does. Okay? So if you rewrite that as secant of regular theta equals negative 1, you should be able to answer that question pretty quickly. And that is all I have for you. Questions? Yeah.
What do you do for the theta minus r over 2?
Theta minus pi over 2, which were, oh my goodness, number 10. Tell you what, skip number 10, I'm going to do that in class. That takes a trick. I can show you the trick. It's totally, because the pi over 2 is supposed to be first, right? This is kind of a trick. X minus y. Is this the same as y minus x? Well, math people? No, it can't be. Because subtraction is not commutative. Well, watch this. If you reverse this, is it negative y plus x? Is that right? Yeah. And now you can factor a negative 1 out. If you want to switch the order of a subtraction problem, you can pull out a negative 1. This is what that looks like. Let's just say, I'm just going to make one up. Cosine of theta minus pi over 2. It's really the cosine of negative 1 times pi over 2 minus theta. And here's the total fun. What happens when you plug a negative into a cosine? Does it switch or stay the same?
Which is,
Cosine?
isn't it even?
Cosine is even.
Oh, it says stay the same.
Stays the same. So it should be the cosine of, in other words, plugging a negative into cosine doesn't make any difference. It's as if you never did it in the first place. So you can rewrite the right-hand side to look like that. Or did they use cosine? Oh, they didn't use cosine, they used sine. Same difference. Oh, sign is different. Never mind, skip number 10, I'll do it.
There are a couple others that have that, like three.
There are water nutters. Worksheet, I'm going to give you a string copy. And I'm gonna burn it right down. I'm kidding. Tell you what, all the ones that have theta in front, skip for now. That actually just cut your homework about into like 2/3 of what it used to be. Congratulations. Stupid worksheet. I mean, lovely. Creative worksheet. To be continued. But pretty much all you need to do for tomorrow, number 1, number 2, number 6, 7, 8, and 9. 1, 2, 6, 7, 8, 9. So 6 out of 10. Alright, we've got about 4 minutes, so go to it. We'll go over the other stuff when we return. All those who are listening at home, God bless. Take care. Ciao.